So as I mentioned, in Rosen 1.3.2, there's a bunch of different identities. And I just want to call your attention to a couple of them. So a couple of the very important ones, just to draw your attention to them, these are all contained in Table 6 of this particular section right here. So in Table 6, it lists a whole bunch of identities, 19 of them. And that's why I'm only going to look at a couple of them. So the ones that I want to draw your attention to are as follows. So in particular, the distributive laws. So the distributive laws are stated as follows. So what's going on right here? Well, the way that you want to think about this is you want to think back to arithmetic. And you remember that we had expressions like this. And we knew how we can distribute this multiplication across that addition right here. And so we knew that this is equal to that expression. These distributive laws are basically the same exact idea. We have operators, multiplication and addition right here, and instead the operators are going to be ors and ands over here. And so what it tells you is how to distribute this or across an and it tells you how to distribute this and across these ors over here. And so the way that you would do it is, for this first identity, you're going to take the or, you're going to put it with a Q, and you take the or and you put it with the R. It's exactly analogous to how we did distribution back in arithmetic days over here. And once again, to be able to prove this particular identity, what you would have to do is you would have to draw out some massive truth table. And we don't really want to draw out that massive truth table because if you were to look at it, the way that you would prove this thing is as follows. You would have to have a P, a Q, an R, and then you would have to look at the compound expressions, P or So it's tedious enough just to draw out and initialize our truth table right here. What we'd have to do is we'd have to go through and look at the truth value of each one of these and verify that these are the same. And so you can go ahead and do that if you wanted to. So for example, let's just do a couple of the rows right here, just for the fun of it. So in this very first row right here, all of my variables are true. We have a true or, so I don't even care about that part because I know that is automatically going to be true. In this one, I have true or true is true and another true that's also true. And, oh, it's actually going to turn out to not be too difficult to fill out the first few rows of this. It's just going to be really tedious. So I'm going to go ahead and leave that up to you as an exercise to be able to prove that those two are actually logically equivalent. So I want to make a really important note about these identities over here. These identities are not meant to be memorized. Don't memorize them just to memorize them. What you want to do is understand them. So similar to the fact that Whenever now you look at an expression like this, you didn't have to memorize that you can distribute multiplication across addition in this fashion right here. You understand it, and so it comes naturally. And how did you understand it, and how did it come naturally? Through practice, through lots of practice. And so what I want you to do is, after this video, go to table 6 in this particular section of Rosen right here and look at these identities. Practice with them. Look at different ways that you can evaluate them with different truth values over here. Look how you can change different compound expressions by using these identities, etc. And in fact, we're going to get some practice working with these things in a subsequent video. But I want you to go ahead and look at these identities and really understand them. Don't try to memorize them just by rote memorization.